and this is number of mole of A minus over 1 kilogram of solution. So the solution part can be cancelled out. So all you end up is actually just N HA over N A minus. Okay, so if you have a buffer solution, then you can calculate your pH. Okay, use this general equation. Okay? So with these ideas, so let's go to our final page, page 15. Okay, assuming today you have acetic acid, okay, CH3COOH, okay, dissolved inside your water. You're going to have the H plus and the CH3COO minus. Okay, you have 0.1 m not of this in the beginning. Okay, so this is the initial. So the first questions. Sorry, there's some more information I need to give you. So for these equations, the delta G naught is equals to 27.15 kilojoules per mole. Okay, and the first thing I want to ask is, what is your equilibrium constant, KEQ? Okay, so this is exactly the same questions we encountered previously, right? Because we know the delta G naught is going to equal to negative RT natural log KEQ. Okay, therefore the KEQ is going to equal to exponential negative delta G naught over RT. Okay, and delta G naught is this. Okay, RT is, okay, again 298K. R is 8.314. So if you calculate that, you'll get a number of 1.75 times 10 to the negative 5. Okay? Okay, second questions. Okay, I want to know what is the pH of 0.1 m naught acetic acid. Okay, so we actually go through this previously, right? This is a weak acid. Okay, so you're going to do this iteration again. Okay, so once you know your K is going to equals to your A H plus times your A minus divided by your A CH3 COOH, right? So you're going to use 0.1, okay, ICE. Change will be minus X, produce X, okay, and then eventually have 0.1 minus X for your acetic acid, and once you reach equilibrium, you have X for your H plus and X for your CH3COO minus, okay? So again, on the top will be equals to X squared, but right now it's activity, right? So it's gamma plus minus squared times your X squared divided by 0.1 minus X. Okay, and this is going to equal to lag constant. And again, you have two variables with one equations. So what you should do is actually assuming your gamma plus minus equals to 1. Do the calculations. Okay. So if you do that, you'll get your X is equals to 1.31 times 10 to the negative 3 when the gamma plus minus is equals to 1. Okay? And then once you have this one, you can recalculate your I, and then recalculate your gamma plus minus. What you're going to get is actually gamma plus minus. It's going to equals to 0.965. Okay? So you put this 0.965 back to here, recalculate your x, then your x is going to equals to 1.36 times 10 to the negative 3. Okay? And of course, you can go back and do the calculation of your gamma plus minus, and it's actually equals to that again. So you stop. Alright, so now you know, okay, at equilibrium, that's the concentration of your H plus. That's the gamma, okay, for your solution, right? So now you need to calculate your pH, because your pH is going to equal to negative log 10 A H plus, right? And that's equal to negative log 10 gamma plus minus times your M plus. Okay, so it's equal to negative log 10. Gamma will equals to 0.965. M plus will equals to 1.36 times 10 to the negative third. Okay, so if you calculate this, you've got a pH value of 2.88. Okay. So the last questions I want to ask. Okay, so if today you have this weak acid, and then you're going to add in a small amount of strong base. Okay. So the question number 3 is actually if you add in 0.01 M naught NaOH solution, okay, aqueous solution, what is the final pH? Okay. So on the hangout I type 0.1, but it should be 0.01. Okay. So how can you solve this? So let's use the ice table again. So in the beginnings, let's say initial you have this much. Okay? And then you're going to add in your sodium hydroxide. Okay? And then you reach this. Okay? So in the beginning you have 0.01 M naught. Okay? So what this is going to do is actually it's going to consume this guy. Okay? This guy. So when you have this, you know eventually this one will be consumed completely.
I don't think we have H plus in there instead of water.
Why not?
Because a weak base, a strong base with weak acid, it becomes neutral.
So you can see, you know the absolute quantity. So this is a lot more than this.
I'm talking about the product.
So in the product, what's going to happen is actually this guy is going to, so consider this one as OH minus, it's equivalent, right? Again, OH when it's dissolved in water, this one becomes OH minus alone. This one is a base. It's going to react with acid. Okay, so where's the acid from? It's from here, right? But the source of this guy is here. Okay, so you know this is super huge amount. This is just little amount. There's 10 times difference here. That means this one is going to consume 1/10 of this species, and it becomes neutralized. This one, the only effect of this one is provided by an ionic strength. Okay, basically after reaction, after reaction of this guy with that guy, NaOH is gone. There's no NaOH. There's no OH minus species inside your solution. All you left is actually Na plus. Okay? And after that, once you reach equilibrium, what's going to happen is actually you can consider that. That's the condition you have. Okay? And then this is going to further dissociate based on the equilibrium constant. Okay? Yes?
Are the water plus sodium H2CO?
Yes, eventually you're going to have a lot of water here. But water is just a solvent. It did not contribute to your equilibrium constant.
But what is the plus
You mean this?
salt plus water, right? The product of
Okay, let's do this, okay? So assuming you don't add in any sodium hydroxide, you have CH3COOH, you have H plus, you have CH3COO minus, you have H2O. Everybody agree with this? That's the initial condition before you add in any sodium hydroxide. These are the species exist inside your container. Agree? So after you add in the sodium hydroxide, so you're going to put in a lot of Na plus OH minus into this species, right? So this guy is going to consume this. Okay? And once you consume this, what's going to happen? If you remove this, the reaction will move to the right, right? Because the Le Chatelet principle tells you if the concentration of this guy decreases, to maintain your equilibrium constant, the reaction to go this way. That means this guy, originally, he can only produce a certain amount of this. But since this guy is keeping removing, so this guy will keep producing the H plus in the end. Okay? So, after you add in the sodium hydroxide, okay, this guy is going to consume this and produce a lot more H2O. Okay? But at the same time, this guy is producing a lot more H plus as well. Okay? So, after you mix them and after they reach equilibrium, this guy will be consumed out completely. Therefore, inside your solution, you're going to have CH3COOH, H plus, CH3COO minus, a lot of H2O plus a lot of sodium ions. Okay? So, if you have this, okay, you compare to the original situation, the only difference is actually just this guy, right? This never actually shows up. Alright? So the effect of this guy is going to affect your ionic strength. Therefore, it's going to affect your gamma plus minus. Get it? Alright. So, in the end, the effect is actually going to consume very much of CH2COH inside your solution. Okay? But it's still going to produce some. Okay, so after you reach this, it's going to produce minus X and produce X. Produce X. Yes. Alright? Okay. And when you do this, because you know this is going to consume that much, right? Once you consume that much, actually you're going to generate that much of this species. So this will be plus 0.01 here. Okay? So in the previous page, we say the pH. How do you calculate the pH of a buffer? Okay, this is going to equal to your pKa minus log 10 times your gamma plus minus times your NHA over Na minus. Okay? You know your pKa, right? So you know your equilibrium constant already, so you can calculate your pKa. Can you estimate your gamma plus minus? You can, right? Because you know what's you can calculate what's your x using your equilibrium constant. Okay? And then once you estimate this, you will know your gamma plus minus. So you are going to know this. Okay? And you know the ratio between these two. The number of moles of your HA, which is this guy, okay? Number of mole of your A minus, which is this guy, which you can actually all calculate this out by yourself. Then you will know what's your pH. Okay? Very important. Need to know this. Okay? Work for it, okay? And with that, we are going to conclude this semester. Alright, so I think before I finish, the only last few words I want to say to you is actually I hope this class provides you some idea about the physical chemistry for sure. The second thing is actually I know many of you is not chemistry majors, so if you're doing great for this class, it's fantastic.